Hello everyone. Welcome back to our second session for today's IAP Climate Science and Policy Talk. And today what I'm going to talk about is a very brief introduction to the economic and policy issues of environmental policy and climate change. And this is also going to be our first talk in the next series of 3 talks focusing on climate policy. And before everything, my name is Minghao. I'm a first-year PhD student in MIT Institute for Data System and Society. My research interest is in the air pollution policy issues, mainly in China. So if you are coming to this session, want to learn more about specific United States climate policy, we are not going to talk a lot about this in this session, but we are going to talk about that the day after, tomorrow. And today's lecture will mainly be something like a conceptual framework of how we will think about the environmental policy and what's important in environmental policy and how do we evaluate a climate policy. And IAP has been running this talk series on climate policy for a long time, and I want to thank the previous contributors, Paul Kishimoto, Michael Davison, and Sam Houston. Okay, and so I'm going to talk about 30 to 40 minutes and leave the rest of time for questions. And what we are going to do here in the next 30, 40 minutes is we are going to try to answer the 3 questions. The first is why we need an environmental policy and what is special about public policy in environmental domain. And secondly, what are the policy options we have in order to deal with the climate change. And third question is when we have a climate policy, how do we evaluate whether the policy is good or not? Okay, so we start with the very fundamental question of why we need an environmental policy. So we even take one more step back. We ask why we need a public policy. Well, the answer might be from different directions. But if you ask why we need a public policy, we basically assume that people cannot achieve to the so-called optimal solution themselves without the rules telling them how to do that. Well, a very common scenario that people cannot achieve to the optimal solution themselves happens when there are lots of people. So a lot of people have different ideas of what is good, what is bad. Different people have different judgment calls. And secondly, when the resources are really limited. So when we have, so a lot of the people sitting here are graduate students. So when you are coming to a seminar with plenty of free food, there's no policy here. There's no policy there to telling you how much food you should take, because there are unlimited food, and everyone take what they think to be optimal for themselves. So overall, people as a whole, the whole society achieve the optimal solution itself. But this is not often the case when there are a lot of people involving and the resources are really limited. And the public policy is very important in the environmental science domain, mainly because that people has different understanding of what good environment is. And here's a picture showing that this is a chart showing the 10 worst cities with 10 cities with the worst air quality in China and in the United States. And as you can see that because people probably have different judgment calls of what an acceptable air quality is. Like if a very intoxic, a very dangerous air quality considered by American people might be considered as acceptable by Chinese people. Well, this is the first point that different people have different ideas of what a good environment. Well, even people have safe judgment call, there are still a lot of problems in environmental science domain, and that's what's so-called the tragedy of the commons. And I will play a short YouTube video here. It's about 1 to 2 minutes, and hopefully
this is a model called Little to Do with the Commons, and tragedy is kind of dramatic. Let's say there's some land with grass on it that people use as pasture for their animals. Nobody owns it, and anyone can come and graze their livestock here. We're assuming that people don't communicate or work together, so we would call this an open access field. Let's assume the number of animals this field can feed is based on the quantity and quality of the grass, which is based on the health of the soil, and it can only hold this many animals. This is the carrying capacity. If animals are added beyond this, the grass can't regrow fast enough to support them all. Also, the grass protects the soil from erosion. If too many animals are around, around, the field may decline in productivity, lowering the carrying capacity. The animals will be less healthy and provide lesser quality products, lowering the profit each animal provides. So it's in this group's best interest to keep the number of animals on the field at or below the carrying capacity. But every herdsman that puts an animal on the field will get the direct benefit that that animal provides for them, but they would only share a portion of the cost of the degraded field. If the field were at carrying capacity and a herdsman decides to add an extra animal, the added animal takes some of the food that would have gone to the others. This reduces their value. The owner of that additional animal comes out ahead because even though all his animals are a little bit less healthy, he has more of them. But each herdsman acts under these incentives and will keep adding animals to their herd or let their animals graze longer, so long as it's profitable to themselves. But really, they're all losing out. Kind of like the prisoner's dilemma. Contrast this to a situation where only one person owns it. If they add an extra animal, they're only hurting themselves. They don't do it. Since new people can't be excluded from the field, there's almost no point in boycotting the use because someone else could just come in. None of the herdsmen own the field, and they can see that the field may not be around forever. They see no point in conservation and just try to use it before someone else does. Okay, so we can go.
Okay, we will stop here. So hopefully this video illustrates a little bit about what is tragedy of the commons in the context, in a very traditional context of the grading animals. So we'll briefly summarize a little bit. So there is a open access resource, and here in this context is an open pasture island that everyone can grade the animals in this island. And the island has a certain capacity that it can hold certain amount of animals. And if you get above the capacity, you will lose out in the long term. So if this pasture island if this pasture land is really just owned by yourself, you are going to manage the number of your sheep at the capacity level. Well, this is not the case when there are a lot of people involving. Why is that? That's because that's for everyone. When they get to the capacity level, they make a choice whether they want to add one more sheep or not. And that's because to add one more sheep, the cost is sort of covered or distributed among other people who sharing this farmland, and it is actually more profitable for them to raise one more sheep. And everyone make their own choice, driven by their self-interest, and everyone raise one more sheep, and they finally get above the island's capacity. So economists have been studying the tragedy of the commons phenomenon for a long time, and here we are going to use two economic terms to describe and analyze the tragedy of the commons. And first, what I said, so why the tragedy of the commons happens, that's because of the term called externality. The definition of externality is very simple. So the externality is present whenever the well-being of a single firm or an individual is influenced by one another's action. And in our context of the grading animals, the benefits of the neighbors are directly influenced by the actions of another neighbor choosing whether or not to add one more sheep. And why externality is important, that's because the externality makes the tragedy of the commons happens because when your cost is offset a little bit by people surrounding you, that you are not really making the social optimal solution for the society. And the externality can have both positive externality, where your activity brings extra benefits to other people, and it can also be negative externalities, where your activity brings extra cost, extra harm to other people. And for here, I want to add one more word on why positive externality might also be problematic. So here, this cartoon shows that getting education is activity that has positive externality, because getting education, you pay the tuition yourselves, and you take the time to study materials, getting down the problem sets. But in the point of view of the society, a person with higher education is less likely to commit crimes, or is less likely to do something bad to the society. So getting education is something with positive externalities. But the cost of getting to the education is is just paid by the individual himself. So in order to get a sort of optimal society level of getting education, the society should encourage more people to get more education, and that's what we see in almost every society in the world. And also people with more education are probably going to have a higher salary, and that's also sort of an encouragement from the society to encourage you to getting more education and to do more, to offset a little bit of the positive externality. Okay, and in addition to externality, we also talk about the second term, the public goods. And the public good, the term of public goods is why tragedy of the commons is very difficult to solve. So a public goods is a good that you pay the cost, and but you cannot exclude other individuals from sharing this good. So in the context of the grading animals, people cannot exclude their neighbors from grading animals in the island. And the public goods can be some big things from environmental protection or the national security, but it can also be some small things like cleaning common kitchen. That the cost is covered by one individual, but the benefits are shared by other people as well. Okay, so why we bother talk about tragedy of the commons? Like the tragedy of the commons is sort of the a very important feature behind all environmental problems. And of course, climate change is an environmental problem itself, and climate change is a tragedy of the commons. And why is that? The climate change is a sort of a commons problem because everyone shares the atmosphere. And the greenhouse gases emitting activities have some immediate and tangible benefits. But it also, in the long run, harm the atmosphere, harm the climate system, and harm the human society. But all the negative costs of emitting greenhouse gases are offset by all the other people living in the earth as well. So emitting greenhouse gases has a lot of negative externalities, and that's why we cannot get to an optimal level of greenhouse gases emitting. And secondly, to removal of CO2 emissions is also a public good. A nation or a firm pays the cost to install the scrubber, to install the technology to cut down the CO2 emissions, but everyone can share the atmosphere with less CO2 and share a climate that is cooler a little bit. Okay, but while climate change is one of the most complex tragedy of the commons in the world, and that's mainly because of these three following reasons. First, climate change is highly uncertain, and we will talk a lot more on uncertainty the day after tomorrow. And in the context of grading animals, people sort of understand what the capacity is, and people understand how many ships we all have, but in the context of climate change, it's not the case. We don't really know what the CO2 capacity of Earth is, and it is also a very difficult question to figure out how much CO2 emissions we are emitting into the atmosphere every day and how much greenhouse gases we have in the atmosphere. And not to mention, there are still a lot of people suspecting that the whole mechanism. And secondly, the difficulty of negotiations. One way to address the tragedy of the commons is to increase more negotiations. But when talk about the climate change, there are just so many countries involved, and different countries have just their different values, so it's so hard to negotiate. And we will also talk more about this tomorrow on international governance of the global climate change. And third question is, well, it's really hard for us to reduce the number of the ships, and in the climate change, it's so hard for us to reduce the carbon emissions. Because since the Industrial Revolution, we are just so reliant on the greenhouse gases emissions in our lifestyles, in our industrial, all sorts of activities. Okay, and we will stop here about the discussion on first question, and so we talk about the tragedy of the commons as sort of the common idea behind all environmental problem and environmental policies, and we will, from now on, we will start focusing more on the climate change context. So what are our policy options in dealing with the climate change? And so this is a simplified chart of the human-induced climate change. So the human society emits greenhouse gases, and the greenhouse gases emissions increase the concentrations of the greenhouse gases in the atmosphere, and together with other contributing factor of the climate system, the climate is changing. And the changing climate has all sorts of impacts on the human society. And so to deal with this problem, what we are really trying to do is we can break either one of these three chains. So we can reduce the greenhouse gases emissions from human society, and that is the mitigation and abatement option. We can also reduce, without making effort on reduce the greenhouse gases emissions, we can also decrease the concentrations of greenhouse gases, or trying to modify the climate from modifying the solar radiation or surface land cover, things like that. And if we agree to not do anything about the climate, so we take the climate as given, we can also try to minimize the negative impact of the climate change on human society, and that's what the adaptation policy comes in. And if we choose not to do anything, we can still have one more option, and we can suffer from the climate change. Okay, so we'll talk about in reverse order. So we first talk about suffering, and this might look like a little bit funny at the beginning, but this is also something very serious and under investigation. So suffering simply means to accepting all effects from the climate change. And so these effects including sea level rise, including the shock on food production, including extreme weathers, wildfires, and the loss of biodiversity. And why we also need to analyze the sort of suffering as a policy option. Well, first of all, this is a bottom line for our policy evaluation. So if we come up with a policy option that is even worse than suffering, we may probably want to give that policy option up. And how are the climate scientists, climate policy analyze the suffering option? So we have a business as usual scenario in almost all sorts of climate modeling. And the business as usual scenario assumes that people do not change the way they are going to use fossil fuels, do not change the ways they deal with the climate. So the business as usual scenario, which is coupled almost in every climate model, is sort of a scenario of suffering. And a little bit better, we can have adaptation policy. And adaptation is trying to minimize the negative impacts of climate change on human society and maximize the positive impact, if there is any, of the climate impacts. And adaptation is very context and location specific. And here in this map showing that the different states of the United States actually face different impacts from climate change. So for different states, in order to get adapted to the climate change, they should have their location-specific adaptation policy. And also, so adaptation is something that probably always carry out at the local scale. And to carry out local scale is something good because we don't need that complex international negotiations to agree on carrying out an adaptation policy. But adaptation policy is sort of like the human beings are really trying to get adapted to the climate, and it's just like an evolution process. So we really need to make sure that the climate is not changing too fast, so that we can catch up the pace on how to get adapted to that. But unfortunately, the climate is now changing very fast. Okay, and we can also have the geoengineering option. So geoengineering option is we don't care about the greenhouse gases emissions. We try to either modify the greenhouse gases concentrations or modify the other factors in the climate system. So mainly there are two main categories of the geoengineering options. We have solar radiation management, and we're trying to modify the solar radiation, and obviously this has nothing to do with greenhouse gases. And we can also remove the greenhouse gases already in the atmosphere. And the geoengineering options there are a lot of options here, and some of them might be very expensive, like putting mirrors in the space to reflect more solar radiation from getting into the earth. And some of them might be very cheap, like growing more trees. But the key point here is there are really a lot of geoengineering options that we don't really know what the side effects are. Like for example, we can inject more stratospheric aerosols into the stratosphere, which sort of as an aerosol layer to reflect more solar radiations back, but we don't really know whether the aerosols will also influence the precipitation pattern or will act as a new source of air pollution or sort of things like that. And once we have the capability to modify the climate, a more fundamental question comes into that: what is the right climate and how much we should modify the climate into? And that is sort of question probably cannot be solved very readily. Okay, so finally we arrive at the mitigation abatement policy option. So we can reduce greenhouse gases emissions through a lot of ways, and three main categories. We can reduce the greenhouse gases emissions through conservation. We can also increase the efficiency of certain industrial activities, and we can of course substitute the fossil fuels to renewable energy, solar and wind, and etc. And to make the firms or individuals really cutting down greenhouse gases emissions, we need all sorts of policy instruments, including command and control policy and two other market-based policy, which we are going to talk about next. So the main category today of climate policy is still the command and control policy. So command and control policy is the government set a certain rule or a certain standard regulating a certain industry or certain firms to only emit a specific quantity of greenhouse gases emissions, or to follow a specific performance level. And this is still a major part of our environmental policy today. And so there are a lot of examples here. We have clean power plants plan in the United States, and there are also all sorts of fuel standards and energy standards. And one key advantage of command and control policy is the command and control policy is very simple in terms of the decision-making process. While the administrative is the administrative EPA or other administrative can simply come up with, will do some research and come up with sort of the optimal standard they think should be optimal, and just give the standard to to the industry and to the firms, and that's everything. And if that's a market-based policy, you still have to come up with some market mechanisms and all sorts of very complex things. Well, there is still a lot of drawbacks. The key drawbacks here is it might be very efficient in terms of there is little flexibility, and you just give the standard to all the firms in that industry, and there's a little space excuse me. There's little space allowing them to change or modify their behaviors themselves. And the second, and the market-based carbon policy here, we talk about the carbon tax policy. A carbon tax policy is for every unit of the greenhouse gases a firm is going to emit, we charge them a certain amount of the carbon tax, which hopefully equals to the social cost of greenhouse gases. We'll talk about social cost later in the third part. Well, from this chart, so on the x-axis we have the quantity of the output that firm choose to produce, and on the y-axis we have the prices and the cost. So the blue curve here, the downward blue curve shows the demand function, shows how prices changes through the changes of the quantities. And the green line here is the private cost of the firm. So the firm will choose to produce at the quantity of Q market when the private cost equals to the price they get. But however, because of the negative externality of greenhouse gases, this doesn't consider the social cost, the cost of the greenhouse gases, the damage of greenhouse gases to the society. So the social cost curve, the yellow curve here, both include the private cost and the damage of the greenhouse gases to the atmosphere. So what the carbon tax is going to do here is we charge every firm a certain amount of tax, just the amount between the yellow line and the green line. So the cost function of the firm will become the social cost function themselves, and they will choose to produce the quantity of the social optimal quantity, the Q efficient here. And we also have the third option called cap and trade. So cap and trade is instead of fixing the unit, instead of fix the cost of certain unit of greenhouse gases, we make a cap of how much CO2 emissions a certain industry or a certain region can emit. And so here in this graph, we can show that this is a comparison between, on the right-hand side is the cap and trade approach, and on the left-hand side is a traditional approach, say command and control policy. So we have the same cap of 30% reduction of greenhouse gases emissions. So plant A has to reduce 180 tons, and plant B have to reduce 120 tons. So overall, they have to reduce 300 tons. Well, in the cap and trade, we set the cap at for the whole industry. We set the cap to let them reduce the carbon emissions of 300 tons. Well, what the benefits of the cap and trade policy is, we set the cap for the whole industry, but we allow the firms in that industry to trade between each other. So what happens here is Plant B has lower cost of abate CO2 emissions, and so the Plant A will transfer about 80 tons of the CO2 permits they have to abate to Plant B, and so Plant B can regulate this 80 tons of CO2 in a cheaper way. And so overall, the industry still save like 300 tons of CO2 emissions, but the cost significantly decrease. Okay, we will probably skip that part. And so so the difference and connections between the cap and trade and the carbon tax. So the carbon tax is we fix the cost of greenhouse gases per unit, and so each firm had their understanding of the cost of the greenhouse gases, but they still choose how much output they produce themselves. Well, for cap and trade, we have a fixed emission cap, and under this cap, we let the firms to transfer the permits and sell the carbon permits, and they sort of determine the carbon price themselves. And the connections between these two policies, first, they are all market-based policy, which are considered as more efficient than the command and control policy because there are more flexibility to allow the firms to make the choice. And secondly, if the tax rate happens to be associated with the amount of the cap, and they actually achieve at the same effects. Okay, and we'll probably a little bit. I will use the rest of the 10 minutes to talk about the third part. And so the third part is when we have a policy, how do we evaluate the policy is good or not? So the general framework here is the cost-benefit analysis, which I guess a lot of people are familiar with. Well, cost-benefit analysis is we're trying to consider the cost and the benefit of a certain policy into monetary terms. And because the benefits and the cost of that policy can happen through the time, and we try to convert the money at different time using discount factor to the net present value, and we evaluate whether whether the benefits is larger than the cost or not. And so in terms of the climate policy, how do we calculate the benefit of climate policy? So if we are talking about a mitigation policy, we get benefits from reduced CO2 emissions. And the reduced CO2 emissions, and the question here is how much a reduce of CO2 emissions can convert into the monetary values. And if we are talking about adaptation policy, it's more like analysis of conventional policy. It's measured either on food production or on energy conservation or on human health. So we'll more talk about the mitigation policy. So a mitigation benefits, in order to calculate a mitigation benefits of a certain carbon policy, we really need to answer these two questions. First, how much CO2 emissions can a policy reduce? And secondly, how much value is a unit of CO2 emissions worth? And here we talk about the term of social cost of carbon. So social cost of carbon is the economic cost of an additional ton of CO2 emissions and what the economic value of it. And in real, to calculate social cost is very difficult, as you can imagine that the CO2 contribute to the global warming in a very sophisticated way, and the warming is also damaging the human society from all perspectives. And what I'm going to talk here is I'm going to introduce a typical way to calculate the social cost of carbon, and that's through the so-called integrated assessment model, which Christoph talks about MIT's integrated assessment model. Here is going to be a result from Yale's model. So the procedures to calculate the social cost is very simple. So you first have a definition of the social utility. And the social utility here really only depends on the consumption. That the more consumption you can make, you are happier. And also, but this is a process happening through the time, so we also have discounting factors, and we also have the population play a part in the analysis. And when we have as I said, the social utility really depends on the consumption, and the consumption is how much we produce through the industrial activities, well, minus the damage from the climate. So we assume that the climate is having an economic damage from all sorts of perspectives. And we are going to catch the damage function in a very simple or probably a little bit unrealistic way, that we are assuming that the damage of climate is a function of the global average temperature. And we are going to evaluate how the greenhouse gases is contributing to the temperature through some simplified geophysical equations. So to recap a little bit, we are going to, so this is what we have in that model. So we have all sorts of economic outputs from the industrial activities. And the economic output has a certain links with greenhouse gases emissions through the emission factors or the energy consumptions we consume. And the greenhouse gases emissions can be modeled, is modeled using the geophysical equations about how much temperature the greenhouse gases emissions changing. And the temperature is associated with the economic damage through this damage function. And the damage plus the overall economic output is going to be our consumption in that society. And the consumption determines determines our utility. So this is going to be a model that optimizes the social utility, and what we are going to determine is the economic output here. Okay, and the social cost of carbon is determined by the ratio of marginal changes of the social utilities per unit of greenhouse gases emissions divided by the marginal changes of the social utility per unit of the consumption. So for example, if the social cost of carbon is $15 per ton of CO2 emissions, what we are going to say here is the damage of a ton of CO2 emissions to our social utility can be compensated by consumption of extra $15 more. And here the graph shows the recommended social cost value of the recommended by the United States governments. And there are also a lot of criticism on this term, and we are only talk about the first term. First drawbacks of social cost of carbon is that the criticizers criticize that the social cost of carbon is not capturing the feature that the climate system is a highly nonlinear system, and there might be a tipping point that beyond this tipping point, say if the global average temperature increases more than 5 degrees, we will probably face a catastrophe event, and we will probably have economic damage that just cannot be calculated. But however, as we can see here, the damage function is sort of a well-behaved function. It's very continuous, and we don't capture a tipping point here. Okay, so in terms of the second question, how much CO2 can a policy cut off, and this is really determined by what type of policy we are talking about. So if there's a policy that's specific, focused on a certain industry, we need to figure out how CO2 is emitted in that industry. So for example, if there's a power sector, and we need to figure out whether the policy is making some regulations on the coal it's going to consume, or whether it's going to regulate on how it burns the cost, and that will all determine how much CO2 benefits we can gain. And a more difficult question is if that's a more general economic policy, like a carbon tax policy, and we try to estimate how much CO2 we can cut down from a carbon tax policy. We are still going to take the benefits of the integrated assessment model, and here is the EPPA model from MIT community. And what it's going to do is there are some basic assumptions on the economics, and we're trying to balance the demands from the supply, and we get a certain price of all the products, and the firms are going to sell these products. And there will also be trade flows between different regions and different industries. And what we'll do here is we're trying to run a simulation without any carbon tax, and so that's sort of a base run. And we are also going to add the carbon tax to the specific industry. So in the model, the firm will facing a higher cost, and according to those assumptions, according to the demand meets supply function, the firm will change the production they produce, and that's how we are going to capture how much CO2 emissions that the policy will contribute to. Okay, and so after talking about the benefits, we will very briefly talk about what the cost of a policy. Well, in terms of the cost of a policy, this is really very complex. It includes a lot of type of costs. So if it's a command and control cost, we have a regulation cost. We have to design the mechanisms, and we have to send the officials to the firms to really make sure they are following our standards. So there are certain costs associated with that part. And we also have an economic impact, which is even more complex. Say we charge a carbon tax on the oil industry. Well, a carbon tax increase their cost, and in the point of view of the firm, when they have higher costs, they will probably decrease. They will probably cut down their employment, which have a lot of complex social impacts here. So, but unfortunately, these two types of costs are really not well understood by the science community yet. Well, this economic impact can sort of be understood through what we call the integrated assessment model we talked before, but the regulation cost is something still poor understood. And what the scientists doing here is the policy we are going to evaluate some moderate policy. Like if it's a carbon tax, the tax rate will be very low, and the scientists will generally assume that because of the tax rate is very low, the economic impact on the society will probably be low as well, and probably can be ignored. But this is something that scientists are trying to learn more about. And we can talk more about the technology cost. So if there is a command control policy and it's regulate the firms, say power sector, to decrease its CO2 emissions by 20%. And what the firms will do is the firm will try to find the most economic efficient technology that tries to reduce this CO2 emissions. And here this graph shows abatement cost curve of the CO2 emissions. So here we have three types of technologies. We have energy efficiency technology. We have this is probably on the technology focusing on the land use cover, and we also have a technology that's focused more on the cleaner power. So analysts have been analyzing that the technology with the highest cost is the technology that we're trying to transfer into a cleaner energy form, and that's probably be very expensive. While some technologies can even be achieved with no cost, and that's the energy efficiency. That's the economic benefits you gain from reduce your energy consumption is high enough, and you even don't need to consider about the greenhouse gases benefits of this sort of policies. Okay, so we'll close the discussion very soon, and we will focus on real-life cases of how cost-benefit analysis analyze a specific policy, and CBA, the cost-benefit analysis, has already been widely used almost in every policy making in the EPA. And if you go to the EPA website, you can check their analyzed report for the policies in the last 5 to 10 years. But things might change. Who knows? So we will here talk about a case about a vehicle greenhouse gases emission standard, and the potential cost of this standard policy that comes from. So there are compliance costs, which includes the technology installation cost, and because of that the cars are made more fuel economy, and the people can generally driving longer time using their vehicles, and there are accidents and noises and congestion costs associated with a longer use of the vehicles. And we also have potential benefits which comes from the fuel saving and the greenhouse gases benefits, air pollution benefits, and reduce of refuel and etc. So here the graph shows the first two rows are the economic cost of the policy. So the compliance, here's the compliance cost, here's the accident and the congestion associated with a longer time use of the cars. And this rows talk about the benefits of the policy. So we have social cost of carbon, and as you can see, this is very uncertain based on what discount rate you are using and what climate scenario you are considering. And so there are also air pollution co-benefits, and as we can see here, the main benefit of this policy is from the fuel saving. So when you make the vehicles more fuel economy, and the benefits of saving more fuels can actually be large enough than the two costs. So if you consider, this policy will pass the cost-benefit analysis when you include all benefits, especially the benefits from the fuel saving. But if you do not care about other benefits, you only care about the greenhouse gases benefits, this policy will probably fail the CBA because the benefits from the greenhouse gases reduction is not enough to cover the cost of this policy. Okay, and finally, we also the climate policy also have other benefits on other domains in addition to the greenhouse gases, and that's what called co-benefits. Well, here we talk about air pollution co-benefits of climate policy. So coal-fired power plants in combustion and in operating, it will emit greenhouse gases. While on the other hand, it will also emit a lot other air pollutants. Well, we can by making the regulations on the power sector, we can make them cut down the greenhouse gases emissions. At the same time, we can also let them cutting down the emissions of certain air pollutants. Well, one message to take away is when we talk about the co-benefits, is always a lot more certain than we talk about the benefits of the climate. So when we are considering a policy, well, the policies is absolutely will do good to the greenhouse gases emission, but we are quite uncertain how much benefits we can get. If the co-benefits from that policy is already large enough, we should probably consider to take that policy. Okay, and after talking a lot about the cost-benefit analysis, there are still a lot of problems with that. So as I mentioned before, that the cost-benefit analysis is still not very good at analyzing the low probability but huge damage catastrophe event. And secondly, there is also a lot of discussion and disagreements on how do we evaluate a health of human beings. Well, the general conclusion here is $6 million is how much a life of a human being worth, but you may disagree with that. And thirdly, as you can see, the economic part of the integrated assessment model is still very crude, and we also have a lot of uncertainties in the climate projections and in the climate analysis. So we will still have a lot of uncertainties in the cost-benefit analysis as well. And we also have, and at the sort of a tragedy of the commons, the climate change is a problem of all over the world, but the policy we are going to evaluate is always going to be domestic policy. Okay, we'll stop here and we will just a very brief summary. So so the first question we asked why we need environmental policy. So we need a policy when people are different and the resources are limited. And as for the environmental policy, we use the term tragedy of the commons to capture the features of the environmental problems. And this is, of course, also the case of climate change. And we also have externality and public goods to analyze and describe these things. And for the second question, we have basically four options: suffering, adaptation, geoengineering, and mitigation. And we also have different policy instruments on mitigations as well. And thirdly, how are we are going to use the cost-benefit analysis to evaluate whether climate policy is good or not. And we are going to calculate the benefit of climate policy using social cost of carbon, and the cost of the policy will be captured by using the term of the CO2 abatement cost curve. And the key tool here is we are going to use the integrated assessment model, which had an economic process in there, and the model might also be linked to Earth system model to trying to understand what's going on in the atmosphere. While this tool still has a lot of things to improve, but this is the key tool here we use to sort of evaluate the policy. And I will stop here and to see if you have any questions.
I have a question. So like you mentioned EPA, DOE, my question is, since the government, you talked a lot about policy, since the new government doesn't support the science of climate, what is the future of all these policies? What's going to happen during this 4 years?
Okay. Yeah, so I guess this is really a heated topic, especially at that time. And we will have a special session tomorrow, totally focused on what the climate policy will be like in the new election of the president. But my personal idea here is, well, the new elected president is sort of taking some step backs in the climate change evaluations. Well, as an international student, I really don't have a lot to say about that. But what I can say here is the policy analysis scenario. What I talked a lot in this talk will probably be as the same, but the contents they will evaluate, the content they will analyze will probably be a lot more different, and you can expect to hear more about that in tomorrow's session. Yep.
Do you have any examples of successful cap and trade deals that happened and how they allocated, who's allowed to produce what?
Yep. So this is skipped slides, and so cap and trade is very complex mechanism, because you have to first come up with a cap, and you have to have different mechanisms to allocate the permits and to set up a market to let them transfer their permits. Well, this example shows how California is doing in the cap and trade program inside California, and so this program is probably only launching in 2013, if I got it right. So there are still not enough analysis on whether cap and trade will really be effective or not. But we can take a look of how California do its cap and trade program. So it sets its cap. So it sets a cap based on the annual goal of -2%, -2%, and -3%, and they also have a sort of complex register system that you can, if you are a firm, you can register online, and you can attend they have three auction sessions in the year, and this gives at this three sessions that the carbon price they finally achieve that is something $11 per ton of CO2, and that also gives some of their how much permit they sell. And in terms of the market transfer, this is a chart showing summarized in 2013 and 2014 how much permits are transferred between each firms in that cap and trade program. So I guess what I'm going to say is cap and trade program is really complex, and there are just very little real life cases here already in its way of the cap and trade program, but we can keep focusing on that. While for the the carbon tax, on the other hand, is a little more mature, and a lot of countries and states are trying to test down the carbon tax as well.
Was it, in this example, was it if I am producing cars and, this guy here has cattle, he's producing 100 tons of CO2 and I'm producing 1,000 tons of CO2, was the price of carbon the same for everybody in most cap and trade deals?
I guess the cap and trade, their program is first specific focus on certain certain type of industries. So like they are sort of have similar manufacturer, and they have similar products, and that's how they're going to transfer their permits. So in your cases, if a CO2 emissions, if a CO2 is emitted through agriculture reasons, and the abatement cost of CO2 really is totally different from agriculture sector and the industry sector, and you guys probably cannot agree on the price that you set for each other. So the point of cap and trade is that everyone set the carbon price themselves. Like but like this is more like an economic problem. But if you are small enough, you take that price as given. But if you are large enough, you really have the power to set the price.
Yeah, if I may add on that, so depending on the carbon pricing programs, different industries that are included or not included. And if you're really interested in that, you should definitely come. There's a talk on Wednesday on climate pricing and globally around the world, what efforts are out there, what has been working, and so that could really be interesting.
Yeah.
On that note, and kind of an answer to your question, is that even though we're kind of not in the best place federally right now, a lot can be done at state level. So I know that there are a lot of bills out there. There's 2 carbon pricing bills that have been filed in Massachusetts, along with a number of other climate action bills. So looking up on those, seeing what you believe in, and calling your state legislators and